All right, let's get started on the remainder of the problem set. Now, really, you should be trying these problems on your own and then either going through the video to check them or doing them one at a time and then looking at the video solution. I really want to discourage you from just using this like a note-taking guide because it just doesn't benefit you at all. Might be easier, it's not good for you. All right, so problem 1. Here's an equation, x plus 4 equals 17. Part A, draw a tape diagram to represent the equation. So we've got two terms combined, x and 4, so we want to draw a two-part tape diagram. And one segment is going to be 4, and the other segment is x. And then together they equal 17. Which part of the diagram shows the quantity x? Kind of a, I don't know, I don't want to be mean, but kind of a duh question. The rectangle labeled x. What about 4? That would be the rectangle labeled 4. What about 17? Well, there's two parts of the diagram that show the quantity 17. You could say the large rectangle formed by the combination of x and 4, and also this 17 beneath the bracket. And you obviously could have worded this differently. And then how does the diagram show that x plus 4 has the same value as 17? And that's shown by the bracket beneath the entire tape diagram that is labeled with 17. So we're going to say by the bracket indicating that the combined x and 4 have a value of 17. Okay, problem 2. Diego is trying to find the value of x in the equation 5 times x equals 35. He draws this diagram, but is not certain how to proceed. So it says complete the tape diagram so it represents the equation 5 times x equals 35. So 5 groups of x have a value of 35. And we see the tape diagram already represents 5 groups of x. So we just want to show the equal part, which is this. And then it says find the value of x. So a lot of you just on inspection and knowing your math facts know that if 5 groups of something equals 35 or 5 times some number equals 35, that number must be 7. We could also use our tape diagram and think if you have 35 and it's split into 5 equal parts, we could think it represents this equation. 35 divided by 5 equals x. And again, 35 divided by 5 equals 7. Hence, x equals 7. All right. Let's see. Next problem. Problem 3. For each equation, draw a tape diagram and find the unknown value. So in each of these equations, we're going to draw a tape diagram, and we're going to find what the value of x would be in that equation. So first one, x plus 9 equals 16. So I've got to make my tape diagram represent the combination of x plus 9. So it's going to have two segments, x and 9. And then the combined value is 16, so it's going to look like that. On the right, 4 times x equals 28. So 4 groups of x equals 28. So my tape diagram needs to show 4 groups of x. So I'm going to draw a long tape and split it into 4 equal groups. And each of those groups represents x, the same amount. And then the total is 28. So again, some of you can just, on inspection, that is just by looking at the equation and your knowledge of math facts and number relationships, figure out what x equals. So in this case, I'm saying what combined with 9 equals 16. So I know 7 plus 9 equals 16, so x must equal 7. I could also think about using the tape diagram. 16 minus 9 must equal x. I could have thought it represents this equation, and 16 minus 9 equals 7, so x equals 7. Over here, again, using math facts, 4 times what equals 28? Well, I know 4 times 7 equals 28, so x is going to equal 7. But I could have used my tape diagram and thought, okay, 28 split into 4 equal parts is going to give me x. So I could have thought 28 divided by 4 equals x, and 28 divided by 4 is 7, so 7 equals x. Problem 4. Match each equation on the right to one of the two tape diagrams on the left. So each of these equations, there's 7 of them, represents one of these tape diagrams could be used to represent them. And we talked about this in the summary. One tape diagram can represent many different equations. So our first one, we've got 9 split into 3 equal groups of x. And our second one, we see we've got a combination of x plus 3 has a value of 9. All right, so our first equation, x plus 3 equals 9, well, that's pretty much just literally what we said here. 3 times x equals 9, so 3 groups of x equals 9, so that's going to be A. 9 is equal to 3 times x, so that is the same as really equation number 2. We've just flipped the equation, so that is also going to be A. Number 4, 3 plus x equals 9. That's really the same as equation 1. We've just flipped our add-ins, and addition is commutative. It doesn't matter what order we do them in, so it's really the same equation. It's going to be B. X equals 9 minus 3. So now we've got a subtraction equation. So we could look at that as equation B. If we take 9 and subtract 3, that leaves x. So this is equation B. X is equal to 9 divided by 3. So if we take 9 and split it into 3 equal parts, we get x. So this is equation A. And 7 plus 7, x plus x equals 9. So this is repeated addition. So even though this is addition and B seems to be our tape diagram that represents addition, this is repeated addition. We're adding x 3 times. So that's 3 times x equals 9. So that is diagram A. All right, problem 5. A shopper paid $2.52 for 4.5 pounds of potatoes, $7.75 for 2.5 pounds of broccoli, and $2.45 for 2.5 pounds of pears. What is the unit price of each item she bought? Show your reasoning. So this is a throwback problem from Unit 5 on decimal arithmetic. So we're finding the unit price. So the unit price is going to be the total divided by the quantity. So for the potatoes, if you've watched the Lord of the Rings trilogy, you know you have to pronounce this word, potatoes. So it's going to be $2.52 divided by 4.5 pounds. For our broccoli, it's going to be $7.75 divided by 2.5 pounds. And for our pears, it is going to be $2.45 divided by 2.5 pounds. Okay, so we have some decimal division here. Woohoo! All right. So the first thing I want to do is I want to get rid of the decimals because they just make things messy. So I am going to, I can keep these as equivalent expressions if I move the decimal point over the same amount in both terms. So to get rid of the decimal in $2.52, I've got to move it over 2 places. So to keep my equation equivalent, I've got to do the same thing here. So now my problem becomes 252 divided by 450. Do the same thing here. Move my decimal over 2 points. Move it over 2 points. So now this becomes 775 divided by 250. And lastly, my pairs. I'm going to do the same thing. Move my decimal point over 2 places in both terms. My dividend and the divisor. So this becomes 245 divided by 250. All right, now comes the fun. All right. 450 won't go into 252, so I've already got to extend that into decimals. 450 into 2,500, I would look at it as 2,520. So this is about 500, this is about 2,500. So I know it's going to go at least 5 times, because 500 will go into 2,500 5 times. So I'm going to go ahead and guess 5. It could be off. 5 times 0 is 0, 5 times 5 is 25, carry the 2, 5 times 4 is 20, plus 2 is 22. When I do the subtraction, I get 270. So I guessed right, it wouldn't have gone 6 times. 450 will go into 270, so I need to bring down another 0 there. 450 will go into 2,700. I'm going to guess 6 times this time, because 450 went into 5 times 450 was 2,250, so I think I'll get another 450 in there. So 6 times 0 is 0, 6 times 5 is 30, carry the 3, 6 times 4 is 24, plus 3 is 27. Oh, look how nicely that worked out. So my potatoes are going to be 56 cents per pound. Now my broccoli. All right. 250 will go into 775. I know twice 250 is 500. 3 times 750 would be 750, so I know it's going to go 3 times. 3 times 0 is 0, 3 times 5 is 15, carry the 1, 3 times 2 is 6, plus 1 is 7. Okay, so now I've got 25. I'm going to bring down that 0 because 250 won't go into 25, but this works really nicely. 250 goes into 250. There's a decimal point there once. And we're left with no remainder. So my broccoli is $3, 3.1, but I want to make it into represent money, so it's going to be $3.10 a pound. And lastly, the pears. All right, 250 will not quite make it into 245, so I've already got to extend it. 250 will go into 2450. Let's see. I know it's not going to be 10. 10 times 250 would be 2,500, and I'm short of that. So I'm going to kind of take a leap here and think, okay, let's see if it goes 9 times. 9 times 0 is 0. 9 times 5 is 45. So 5, carry the 4. 9 times 2 is 18. 18 plus 4 is 22. I get 220 or 200. 250 won't go into 200, so I've got to go a little further into my decimals. 250 will go into 2,000 exactly, because 250 goes into 1,000 4 times, so it will go into 2,000 8 times. So 8 times 0 is 0, 8 times 5 is 40, carry the 4, 8 times 2 is 16, plus 4 is 20. Yay, no remainder. So my pairs are 98 cents per pound. And there is my unit rate for each of those. Okay, let me get a couple more problems. Problem 6. No, come on. Where are you? Right here. All right, problem 6. The sports drink bottle contains 16.9 fluid ounces. Andre drank 80% of the bottle. How many fluid ounces did Andre drink? Show your reasoning. Okay, so again, this is a throwback. This is all the way back to Unit 3 where we were working on percent ratios. So he drank 80% of 16.9 fluid ounces. So a whole bunch of different ways you could solve this. One is you could find 10% of 16.9 and then multiply that by 8 to get 80%. So 10% of 16.9, we can find 10% of something by just moving the decimal point one place to the left. So 10% of 16.9 would be 1.69 ounces. So 80% will be 8 times 1.69. So set that up over here. 8 times 9 is 72, so record the 2, carry the 7. 8 times 6 is 48. 48 plus 7 is 55, so record the 5, carry a 5. And 8 times 1 is 8, plus 5 is 13. So he drank 13.52 ounces. The other thing is I could think of just rewriting this as a multiplication problem because of translates into multiplication. I could find 80% of 16.9. I need to convert 80% into its decimal form. I do that just by moving the decimal point 2 places to the left because 80% would be 80 hundredths, 80 per 100. And I can write 80 hundredths as 0.80 or just 0.8. So I could do 0.8 times 16.9, which is almost what I did there. So 0.8 times 16.9, 8 times 9 is 72, carry the 7, 8 times 6 is 48, plus 7 is 55, 5, carry the 5, 8 times 1 is 8, plus 5 is 13, and then we've got 2 decimal places. So either way you look at it, 13.52 ounces. Always multiple ways you can solve any of these problems. All right, last problem. Problem 7. This is another throwback problem from Unit 3. The daily recommended allowance of calcium for a 6th grader is 1,200 or 1,200 milligrams. 1 cup of milk has 25% of the recommended daily allowance of calcium. How many milligrams of calcium are in a cup of milk? If you get stuck, consider using the double number line diagram. So this is really just asking, a 6th grader is supposed to have 1,200 milligrams. A cup of milk has 25% of this recommended daily amount. So how many milligrams are in a cup of milk? 25% of 1,200. So if you remember, 25% is equal to 1/4, right? When we were looking at the equivalencies between percents, benchmark percents, and fractions. So 1/4 of 1,200. Well, 1/4 of 12 we know is 3. So 1/4 of 1,200 is going to be 300. that's one way we could solve this. We could just do the 25% of 1200, similar to what we did in the one before. 25% of 1200 is the same as saying 25 hundredths times 1200. In 25 hundredths, we could write it as 0.25, so you could do a decimal multiplication problem, and we could use our double number line diagram. 50% is going to be in the middle, and in the middle of 0 and 1200 is going to be 600 milligrams. And then if we split 0 and 50 in half, we get 25%, and 600, the halfway mark between 600 and 0, is 300. So we could also do it this way. But our answer is 300 milligrams. All right.